All right, today we're diving into the incredible story of Dr. Pascale Selinart, a quantum physicist who took a single nagging research problem and turned it into a revolutionary company. Now, for this explainer, we're drawing from a fantastic interview she gave on Under the Microscope. That's the flagship podcast from the Science Talk, which really spotlights amazing innovations in material science and nanoscience. We're going to see exactly how she went from just chasing a single particle of light to building an entirely new kind of quantum computer. And really, this quote is the heart of our whole story today. That feeling, that deep satisfaction of taking something from pure research and making it real. For Dr. Selinart, this wasn't just some career change. It was the spark for a whole new adventure, one that would push the very limits of what we thought was possible in both technology and in science itself. So this begs a really wild question. I mean, we get how to build computers out of electricity, out of silicon, but how on earth do you build one from pure light? How do you actually compute with a photon? That was the fundamental kind of mind-bending challenge that Dr. Selinart and her team decided they were going to tackle. So where do you even start a journey like that? Well, you start with the smallest possible piece of the puzzle. Before you can even dream about a computer, you have to figure out how to create and control its most basic component, just one single, perfect photon. And to do that, they first had to tame what's called an artificial atom. The key to this whole thing is a piece of tech called a quantum dot. Now, think about this for a second. Scientists figured out how to take thousands of atoms and engineer them so precisely that they all act together as one single giant artificial atom. It's an absolute marvel of nanotechnology. And its superpower? It can spit out one and only one photon whenever you tell it to. Okay, but here's the catch. A huge one. A natural atom just spits out a photon in any random direction. It's chaotic, it's messy, and it's totally useless if you're trying to build something. So the goal was to wrestle that chaos into perfect control. They had to force their artificial atom to send its photon down one specific path, channeling it perfectly into an optical fiber every single time. So how do you tame that randomness? Well, the answer, and this was the team's first huge breakthrough, came in the shape of a tiny, perfectly engineered pillar. And this one single innovation, it changed absolutely everything. But this led to a massive engineering headache. These amazing quantum dots, they formed spontaneously. That means they just pop up in random spots all over the material. I mean, imagine trying to build a perfect little house around one specific grain of sand on a huge beach. How could they possibly build something so precise around an object they couldn't even control the location of? Their solution, which they nailed back in 2008, was this brilliant process called in situ lithography. Here's how it works. It's so clever. First, they scan the material with optics to find the perfect quantum dot. That's step one. Find it. Then, once they've locked on, they use a laser to draw a microscopic, perfect circle around it. Step two, draw. And finally, and this is my favorite part, Dr. Selinart compares it to scooping ice cream. They just etch away all the surrounding stuff, leaving behind this perfect little micropillar with that one special quantum dot trapped right in the center. Problem solved. So they had solved the where problem. But that incredible achievement just uncovered the next, even tougher challenge, the quest for absolute perfection. You see, in a research lab, getting something to work 80% of the time is a huge win. But if you want to build a real product, a real quantum computer, 80% is basically a failure. You need to be as close to perfect as possible. And that big push for perfection actually came from the outside. As you can see from the quote, a major figure in quantum computing kind of took her under his wing. He pushed her and the team to make their photon sources not just bright, but something way, way harder, to make them indistinguishable. And that brings us to this really critical idea in the quantum world, indistinguishability. It's like the ultimate form of quality control. It means every single photon that comes out has to be a perfect clone of the one before it. Same exact energy, same shape, same polarization. They have to be perfect twins. Because if they're not, the quantum magic just doesn't happen. So why does this perfection matter so much? Well, it all comes down to a really weird quantum rule. Imagine two cars get to an intersection. They can turn left or right, go their separate ways. But if two perfectly identical photons meet at a quantum intersection, they are forced to stick together and leave down the same path. This effect is what creates entanglement, that spooky, magical connection that is the powerhouse of a quantum computer. So after years and years of work, by 2015, they hit the magic number, 99.5% indistinguishability. And this wasn't just a small step up, it was a complete game changer. All of a sudden, their photon source wasn't just some cool lab experiment anymore. It was now a world-class, must-have component for anyone serious about building a quantum computer. So what do you do when you've created a piece of tech that the entire quantum computing world is drooling over? Well, there's really only one thing to do. It was time to move out of the university lab and start a company. And this was the moment Quandela was born. The way it happened was so natural. Dr. Selenart's PhD students would go to conferences and present their 99.5% result, and the reaction was just electric. Researchers would literally line up afterwards saying, "Yes, I want your source." It was at that point that one of her students, Niccolò Samatashi, just said it. Let's create a startup. You could just feel the momentum building. 2008 proved it was even possible. Then by 2013, their 80% efficiency had the top research groups in the world paying attention. And after they hit near perfection in 2015, well, the path was crystal clear. It led straight to the founding of Quandela in 2017. So after all of that, what does their quantum computer actually look like? It's probably not what you're picturing. Seriously, forget the giant dangling golden chandeliers you always see in photos. This is something else entirely. I mean, the difference is just night and day. On one side, you have that chandelier architecture. These are massive machines that need huge room-sized cryogenic systems to get them near absolute zero. But then you have Quandela's photonic computer. It's a modular rack, and its core is cooled by a little fridge about the size of a suitcase that you just plug into the wall. It's built from the ground up for practicality and accessibility. And the result is a system that's just amazingly friendly to use. It's been accessible on the cloud for a while now. Developers can program it using Python, a language they probably already know. And because it's modular, you can literally swap out chips for different problems. And at its core, of course, is the same world-class photon technology they spent more than a decade perfecting. And this is where the story comes full circle. See, the team started out trying to solve an engineering problem so they could build a product. But by succeeding, they ended up creating tools so incredibly powerful that they started unlocking brand new areas of fundamental science. Dr. Selenart feels really strongly about this. For her, it's not like science is up here and engineering is down here. No, they're equal partners. They're in a dance of discovery together. One just can't move forward without the other. The tools you build today literally allow you to ask the questions of tomorrow. So what kind of new science are we talking about? Well, this is where things get a little weird. Using their perfected tools, they could now create and actually observe a quantum state that was a superposition of, well, of something and nothing. A physical state that was, at the exact same time, both one photon and no photon. Just let that sink in. Dr. Selenart calls this serendipity. It's that amazing moment in science when something happens that you totally didn't expect, and you just don't understand it at first. But if you dig in, if you get curious, you might just discover something totally new about how the universe works. And that feeling, she says, is just fantastic. And that really leaves us with one final thought to chew on. Dr. Selenart's journey shows us that the quest to solve one problem, to build one tool, can end up taking us to places we never even dreamed of. So it makes you wonder, what other strange, beautiful, and fundamental truths are just waiting out there to be discovered by the next generation of tools we build?